Okay, let's do these. Number one, so the power rule says you take the 15/16 down, x to 1 less than 15/16. So it'd be 15/16 minus 1, or 15/16 minus 16/16 is minus 1/16. And if you didn't like the minus, you could write this as 15 over 16x to the 1/16. And if you don't like that exponent, you could write um, 15 over 16 16th root of x, because that's what the 1/16 power says. This one is just x to the negative 17, so the derivative would be negative 17x to the negative 18, or negative 17x over negative 17 over x to the positive 18. The ninth root of x is the same as x to the 1/9, so the derivative would be 1/9 x to 1 from 1/9 is negative 8/9, which is the same as 1 over 9 x to the positive 8/9, or 1 over 9 ninth root of x to the 8th. This one's pretty straightforward. The derivative would be 4 t to the 1 minus 2 t, because this is to the 1. 1 times 2 is negative 2 t to the 0, but t to the 0 is 1, so we don't have to write that, and the derivative constant is 0. So we got that. This would be 12 times 4 is 48 t to the 11th. This is the 1/2, so that'd be negative 7 times a half, negative 7 halves, t to the negative 1/2, which would be the square root of t in the denominator. And this is 4 over t is 4t to the negative 1, so the derivative of that would be negative 1 times 4t to the negative 2. This could also, that part could also be written as negative 4 over t squared. This one, without knowing a product rule, two functions multiplied, we better multiply it in so that we know how to do it. Well, this is x to the 1/2. So if we take x to the 1/2 times x squared minus 4 plus 4, we get x to the 2 1/2 plus 4x to the 1/2. And so now we can take the derivative, and that would be 2 1/2 x to the 1 1/2 plus 1/2 of 4 is 2x to the negative 1/2, and this would be like the square root in the denominator. Again, we don't have a quotient rule, so we just divide the x into both of these, or think of this as x to the minus 1 times this stuff. Anyway, we get x to the 4th plus 2x to the minus 1, or 2 over x, and the derivative of that would be 4x to the 3rd minus 2x to the minus 2, and the x to the minus 2 is just x squared in the denominator. Okay, that's 1 through 7. 8. says, if we got this equation, find the equation of the tangent line. So that says the tangent line is L of x. We've done that, and we're supposed to do it at 2. So right here, find it at 2 in the x. So that's f prime of 2. So the derivative is 12x squared minus 8x plus 0. We've got to put 2 in there to get f prime of 2. So f prime of 2 would equal 4 times 12, 48, minus 8 times 2 is 16. 48 minus 16 is 32. X minus 2 plus f of 2. So that would be 8 times 4, 32, minus 4 times 4 is 16, plus 11, so that's 27. Okay, this one. Find analytically values for where the derivative is equal to 0. Not f of 0 or f prime of 0, but where the whole derivative is equal to 0. For what x's? So we're finding x's where the slope of this function is 0. Now, if you graph a cubic, it's probably something like this, and it's going to be a couple places where the slope is 0. So let's find the derivative to start with. So let's get another piece of paper here. The derivative of this would be 3x squared plus 6x minus 189. 3, lower by 1. 2 times 3 is 6, lowered by 1. And 1 times that is that, lowered by 1. We get this. That's f prime of x. And they want to know when that's equal to 0. I think 3 goes into all that, so it would be 3 times x squared plus 2x minus 63. And so setting, this doesn't look like the one we did in class or whatever, but it's similar. So I'll continue with this one. This must be a little bit different problem. Anyway, so continuing on with this, we could probably factor this part. And see, x and x 7 times, so plus 9 minus 7 will make the 63, plus 9x minus 7x is 2x. And so x equal negative 9 or x equal 7. That's the two places where the slope is 0, at negative 9 or at plus 7. Okay, so if we want to list them like they said, negative 9, comma 7. Okay, well, I hope the other ones are not different from what the actual assignment is. This is a print off from the PDF, so we'll see. Let h be a new function which is 3 times f of x minus 4 times g of x. Determine h of 2. Well, we know f of 2, we know g of 2, and so h of 2 would be 3 times f of 2 minus 4 times g of 2. And f of 2 was 5, so we got 3 times 5, or 15, minus, and g of 2 is minus 3, so we got minus 4 times minus 3, which is minus 12. So we got 15 minus or plus 12, which is 27. Now we're supposed to find the equation of the tangent line. Okay. Oh, we didn't find f prime of 2. H prime of 2. Well, that would be, since h of this is this, then h prime of 2 would be the derivative of this, which would be 3 times f prime of 2 minus 4 times g prime of 2. So 3 times f prime of 2 is negative 1/2 minus 4 times g prime of 2, which is 2. So we got negative 3/2 minus 8, which is negative 1/2, negative 9/2. Okay, so keeping that there, moving to B, find the equation of the tangent line at 2 h of 2. We just figured out h of 2 was 27, so we're doing it at 227, and the tangent line at a equal 2 is f prime, which we just figured out was negative 9/2 x minus 2 plus f of 2, which is 27. So there's the equation of the tangent line. And now they create a new one, P. All right, so let me turn my paper here and do P, which is minus 2f of x plus 1/2 of g of x. Is P increasing or decreasing, or neither, at a equal 2? Well, it depends on what the slope is. If the slope is positive, it's increasing. If it's negative, it's decreasing. So we're to find P prime of 2, which will be negative 2 times f prime of 2 plus 1/2 times g prime of 2. So we get negative 2 times f prime at 2 is negative 1/2 plus 1/2 g prime of 2, which is 2. So we get 1 plus 1, which is 2. So the function must be increasing. That's 10. 11. Now I'll do this one. I did it the complicated way in class. Now let's just do it the easy way. At what points is this not differentiable? Well, P is not differentiable at a cusp and at a cusp. And it's got limits all the way through, and it's got values all the way through, and they're all equal, so it's continuous, but a cusp and a cusp. This one's got a cusp and a cusp. Both of them are not differentiable at x equal minus 1 or x equal 1. Those are the two places it's not differentiable. Then it says r of x is p of x plus 2q of x. At what values of r is it not differentiable? Well, that would be the same, because these cusps will continue to have cusps. So, same places. And in class, I showed how these added and became something that looked like this. Okay? But there's still a cusp here, and there's still a cusp there. C, r prime of negative 2 at negative 2. So r prime will be p prime of r prime at negative 2 will be p prime at negative 2 plus 2 times q prime at negative 2. And p prime is just the slope of this, and that one is negative 2. 2, and q prime, the slope of that is plus 3. And so we get the r prime at negative 2 to be negative 2 plus 6, which is 4. And determine r prime at 0. Okay, so if we have this here, let me put this on top of that. There is, but we just have to do it at 0, so it'd be r prime of 0 will equal p prime of 0 plus 2 times q prime of 0. So we look at the graph, and p prime at 0, that's this one, p prime at 0, the slope at 0 is a half, and the q at 0 is 0, so 2 times 0, we get 1/2 is the slope, and that's what we had in the picture in class. The slope of the added functions was a half there. And finally, part D. It's on the next page in this printout, so I'm going to put it up above. And it says, find the equation of the tangent line at 2r of 2. Well, there we found out it was just 4 all the time. But let's just do it. It would be L of at a equal to L of x, the tangent line, would be f prime at 2. And I think we figured out f prime at 2. Let's see. Or of r. R prime at 2 was, well, we did at negative 2. So we need to find r prime at 2. So, trying to keep all these papers organized here. Move that up. We're going to do the same thing again, but with not 0, but 2. So, p prime at 2 plus 2q prime at 2. So p prime at 2, that's this one, has a slope of 2 plus 2 times q prime. And q prime has a slope of minus 1. So 2 plus 2 times minus 1 is 0. So we're going to have 0 times x minus 2 plus p of 2, which is 4. You can go back and do p of 2 plus 2q of 2. P of 2, the height of 2 is 2, and the height of q is 1, so plus 2 times 1, and we get 4. So there's the equation of the tangent line at 2r of 2. That got kind of messy, got all over the place. Let's see here. I did 12 in class. It's messy, but it's straightforward. But 13, I did this not in class recently, but earlier on in the class. Early when we were talking about how to do the derivative of something to the x, like 6 to the x or e to the x. So let's go through this one nice and slow. So it says use the limit definition of the derivative to show that, well, let's see, the limit definition of f prime of x is f of x plus h. If we were doing that a, it would be a plus h, but I'm doing it x, so x plus h minus f of x over h. But we're doing a to the x, so we're going to have the limit as h approaches 0 of a to the x plus h minus a to the x over h. And they want us to use this to show we can get that. Well, there's a, this splits up into a to the x and a to the h. And so there's an a to the x in both, so I can pull that out, and I can get the limit as h approaches 0 of a to the x times a to the h minus 1 over h. Now I did that with x to the 6 instead of a to the 6. So this is a more general thing. Okay? Explain why then we can do this. Well, the limit is looking at anything that's varying with h. This changes with h, this changes with h, this doesn't. So we can pull that out. And so it's a to the x limit as h approaches 0 of a to the h minus 1 over h. Okay? And now it says, try to figure out what this comes out to be if a is 2. So they want us to look at just this part. Notice they didn't show the a to the x. So we're doing just this part, and we're going to put 2 in for the a. So I pull up my calculator and type in 2 to the x, minus 1. Oh, and that's my numerator, so I got to go back here and insert a parenthesis, close it with a parenthesis, divided by x, and then go to the table, and we're going to go close to 1, and we're getting about, when a is 2, we're getting the limit as h approaches 0 of 2 to the h minus 1 over h to come out to be approximately 0.6931. And I can do it from the negative side also, negative 0.0001, and we get same number. Okay. So then, oh, and we're supposed to do it with 3. So the limit as h approaches 0 of 3 to the h minus 1 over h comes out to be approximately. So all I have to do is go back to my y equals, change the 2 to a 3, and then go second table, and it's telling me small negative and small positive. It's 1 point, see if I can get that so you can see it better, 1.0986. 1.0986. Okay? So we did what they said to do there. It says, wouldn't it be nice if we could get 1? This came out to be more than 1. This came out to be less than 1. This is really close to 1. 3 was pretty close. 2 was further away. So let's try a number in between. Let's try, this is what they were hoping you would do. Try something like 2.8. and I need to keep inserting, and it is 6, 6. We'll try that. And so I go to the table, and I'm close to 1. I'm a little bit low, so I'll go back here. How about 2.76? Oop, second table. That's a little bit too much. So let's go to here and do 2.72. And table. Oh, we're getting even closer. Let's go to 2.71. Table. Now we're a little bit low. Okay, so go to the y equal and go 2.718 and go to the table. Getting really close, aren't I? Well, hopefully you're starting to recognize what the number has to be. 2.71828, it has to be clearly. Let's take this down to here, and if I put in E, what do I get? Second table. I get the ones that I was looking for. So, part D, you were supposed to just kind of keep changing the A in this till we can come up with 1. And we found out that A would have to equal E. And then we're supposed to say, well, what does your work of B and C tell you about these? Well, what they're hoping you would figure out is that when we got these numbers here, that this is LN3, verify, second quit. LN3 is 1.00986, and ln of 2 is 0.06931, blah, blah, blah. So it's telling us that if we have 3 to the x as our function, the derivative is 3 to the x ln3, and similarly for 2 to the x would be 2 to the x ln2. That's what they wanted you to see on D, E, and then F. And what's the particularly important function about e to the x? That the slope and the value are equal, which is what I really stressed when we first saw it. So 13 is just an attempt to review what I lectured you about on this stuff when we first learned how to take the derivative of this and of f of x equal e to the x. Okay?